Hello, I welcome you all to this class. Now in this video we are going to discuss about the moment of inertia. So in previously we already know about the center of gravity or centroid, right? So centroid, how we calculate actually that area into distance. So that centroid we call it as a first area moment is known as a centroid, right? And the second area moment is known as the moment of inertia. Second area moment means what? That area into square of the perpendicular distance is a moment of inertia. So you can say the second moment of area or a quadratic moment of area is known as moment of inertia. So here we can start that you can say here the first area moment, first area moment is known as what? Center of gravity, right? Center of gravity. And when you have a, that means center of gravity, how you are finding that example, you can say that, let's say this is the example, the center of gravity is the area into distance by summation area, is it or not? So now you can say that if you have to find out the moment of inertia, so moment of inertia is what? That you can say the moment of inertia is what? Is known as second area moment, right? Second area moment. So second area moment is known as the moment of inertia. Means what? That means moment of inertia we can say the area into distance of square of the perpendicular distance. So you can find the moment of inertia about x-axis or about the y-axis. Also we need to find out the moment of inertia about the z-axis. So when we are finding the moment of inertia about the z-axis, that moment of inertia we call it as a polar moment of inertia, right? So here if you have to imagine that you have to find out the moment of inertia about the x-axis, right? So to understand this we will draw one plane, that is xy plane you have. So here let's say this is your y-axis and this is your x-axis, okay? And any shape is there whose moment of inertia you have to find. This is the irregular shape, right? So it means that this shape is having area. Let's say the area of this shape is A, and if you have to find out the moment of inertia about the x-axis, for x-axis the perpendicular distance is what? Perpendicular distance is y, that is vertically is the perpendicular distance. And when you have to find out the moment of inertia about the y-axis, then for y-axis the perpendicular distance is the horizontal distance, is it not? So it means that you can say when you have to find out the moment of inertia about the x-axis, that means Ixx is equal to what? Area, the product of area and the square of the perpendicular distance. So for x-axis the perpendicular distance is the vertical, and for y-axis the perpendicular distance is the horizontal, right? So Ixx is equal to what? Y square means square of the perpendicular distance into area of that particular shape whose moment of inertia we have to find, right? Similarly we need to say that when you have to find out the moment of inertia about the y axis, it means that for y axis the perpendicular distance is the horizontal. It means you need to say x square, the square of the perpendicular distance into area of that particular shape, right? Now so it means that moment of inertia we are denoting by letter I, right? So that you can make a point here, you can make a point that moment of inertia, in short I'll write down MOI, okay? So moment of inertia is denoted by I, right? Is denoted by I we are denoting for that axis if it is lying on the plane, right? For axis lies on the plane, right? Lies on the plane, okay now. and one more notation is for the moment of inertia, that is the J, right? So and you can say the moment of inertia is also denoted by the letter J if for what? For axis perpendicular to the plane, right? Perpendicular to the plane means what? That for Z axis, right? For perpendicular to the plane, okay? Perpendicular to the plane. Now, so you can say that the moment of inertia is what? The moment of inertia is a geometrical properties of an area which reflects that how its points are distributed with regard to the arbitrary axis. Means you need to see that how an area which reflects how its points are distributed with respect to the arbitrary axis, right? And then we can say that what are the use, means what are the application of moment of inertia, that why we are studying. See, actually whenever we initiate anything, means when you try to study anything, okay, that two things we need to know, that why and how. Why means what? That why I am doing this work, okay? And how means what? How you can do. If you know the why, then the how will be easy, right? So now we need to see that if you are studying about the moment of inertia, so as an engineer you should know that why you are studying about this topic, right? Means what are the uses in your future. So moment of inertia basically we will use in the structural engineering. Structural engineering means what? That when you have to design the beam or the columns, right? So whenever the beam is subjected to the load, that beam is going to be deflected, okay? And because of that deflection there is a stress will induced, right? So that in that case, whenever you have to find out the deflection in a beam or the stress induced in a beam, that the moment of inertia will plays a very vital role. That is, bending equation is there, m by I is equal to sigma by y. By using that empirical relation you will find out the bending stress in the beam. So these are the practical application of a moment of inertia. Now you need to see that whenever any shape is given, right? So first of all you have to find out the moment of inertia either about the centroidal axis, okay, or in some cases we need to find out the moment of inertia about the axis which does not lie on the centroidal axis, means the rather than the centroidal axis. So in that case we will use one theorem. That theorem we call it as a parallel axis theorem. So basically two theorems we will study in this topic, that parallel axis theorem and the perpendicular axis theorem. So first of all we will see the parallel axis theorem. So here you can say, just wait. So this is your, make a subheading that parallel axis theorem, right? Parallel axis theorem. So we will try to learn this theorem by using one schematic diagram. Means parallel axis theorem is used only when you have to find out the moment of inertia about an axis which is not its centroidal axis. Means if you have to find out the moment of inertia of a shape rather than that its centroidal axis, then we will use the parallel axis theorem. So let's see here that we are considering this one base I consider, let's say that the base name is AB, right? And at a certain height from this base one shape is kept, right? So this is a shape whose moment of inertia, means that is the shape, and you have to find out the moment of inertia about the base AB, okay? It means that whatever the shape you have taken here, this shape is having its centroidal axis. Let us imagine the centroidal axis of this given shape is here. It may be somewhere, let's imagine it is here. So we can name this centroidal axis as a CG, okay? Now then you can locate this centroidal axis from the base. Why? Because now your reference is a AB, Is it or not? So let's imagine that centroidal axis is located at a distance of h. Is it or not? Right? Then what actually the centroidal axis is here of this shape, but you need to find out the moment of inertia of the shape rather than the centroidal axis. Means that they are asking that find out the moment of inertia about the base AB. So whenever in such cases will come into play, we will apply the parallel axis theorem. So what is the mathematical relation for parallel axis theorem? It means that whenever you have to find out the moment of inertia of a base AB which is parallel to the centroidal axis, then your, according to this parallel axis theorem, this equation will be IAB is equal to IG plus AH square. Okay, this is the empirical formula for parallel axis theorem. Means by using this you can find out the moment of inertia about the base, where Ig is what? The moment of inertia about the centroidal axis, and A is the area of the shape, this shape, right? And H is what? H you call it as a height of the center of gravity, or the distance between the two axes. Two axis means what? One axis is the centroidal axis and one axis is the base about which you have to find out the moment of inertia. Let's see that Ig means what? That Ig is the centroidal axis. If you are finding the moment of inertia about the x-axis, it means that you need to moment of centroidal axis moment of inertia you have to find about x-axis, and then height is the y bar minus y1. Okay, so here I can write, so please now we can come back. So here we can say that just write down the about the notation whatever we have taken here, that here that it's not functioning properly. IAB is the moment of inertia, MOI is the moment of inertia, right? Moment of inertia about base, right? And IG is the moment of inertia about what? About centroidal axis. Okay, and A is what? Area of the shape. We can say A is the area of shape, right? And H is what? H is the distance between the two axes, or you can say the height of the center of gravity. Height of center of gravity from base. From base means what? From where you have to find out the moment of inertia for particular cases for base. So if you are finding the moment of inertia about the x-axis, so you can make a note, this is the key point you can say for x-axis, right? H is equal to y bar minus y1, or sometime you can write y1 minus y1. Y bar means h1 is equal to y bar minus y1, h2 is equal to y bar minus y2, and so on. So, and if you are finding the y bar is what? Center of gravity, and for y-axis, the here only, that for y-axis h is equal to x bar minus x1, means h1 is equal to x bar minus x1 and h2 is equal to x bar minus x2, right? And so on. So this is what you have a parallel axis theorem. One more theorem we have to study, that we call it as a perpendicular axis theorem, right? So here just wait, that I forgot to tell you the unit of moment of inertia right now. So moment of inertia is denoted by I, we have written somewhere right now. So unit is, you can say here itself, that, or it's come back to here right now, right? So you can say that, just a key point, actually we forgot that. So unit of moment of inertia is meter to the power of 4. If you are taking the distance in meter, it will be meter to the power 4. If it is millimeter, millimeter to the power 4, centimeter, centimeter to the power 4, so on. So right now we'll see one more theorem which we call it as a perpendicular axis theorem, right? So here you can make a heading, that perpendicular axis theorem, right? Perpendicular axis theorem. So perpendicular axis theorem is what? The perpendicular axis theorem is used to find the moment of inertia with respect to a perpendicular axis. Means what? That if you have to find out the moment of inertia about the third coordinate, that is about the z axis, which is perpendicular to the x and y, right? So for finding the moment of inertia about the perpendicular axis, we will use the perpendicular axis theorem, right? So you can write that this theorem here, this theorem is used to find the moment of inertia with respect to perpendicular axis, right? Perpendicular axis means what? That means, let's say here that you have a three mutually perpendicular axis. This is y, x, and this is your z, right? This is your z, right now. So this is how x axis, y axis, and the z axis. This z axis is also known as the polar moment of inertia. Whenever you have to find out the polar moment of inertia, means what? That you need to simply algebraically add the moment of inertia of x and y. So according to this parallel perpendicular axis theorem, you have a relation is that moment of inertia about the third axis, means moment of inertia of a perpendicular axis, which is nothing but the izz is equal to ixx plus iyy, right? So this is your perpendicular axis theorem. And then this izz is also known as the polar moment of inertia, right? So now we can see that few geometrical shape we have to learn whose moment of inertia we need to remember. That the empirical relation is already existing, so it's just a formula you should have to remember for few geometrical shape. That is nothing but the rectangle, circle, triangle, and the semicircle, right? So most of the time in structural engineering, this type of shape is only used, right? If you have a I sections right now, so I section is what? Only the rectangle is involved. Either you can design your column of circular cross section or rectangular cross section, means a square cross section. So in that case, that circular and the rectangle is most of the time is involved, and in few cases we have a semicircular shape is involved, right? So let's start that. You can see here that few geometrical figure name we will write first, and then I'll tell you the empirical relation, which is very important, right? So now you can make a heading that moment of inertia of different geometrical shape, or you can say the shape only, right? Moment of inertia of different geometrical shape, or only shape you can write. First geometrical body we will see, which is your rectangle, right? This is your rectangle, right? So this is your width, we can say b, and this is the depth, which is the d, right? You know the center of gravity of a rectangle is lying at the center at the intersection point where the diagonals are intersecting. So this x is b by 2 and y is d by 2. That we have discussed already, right? If you don't know, you can go through with the previous videos, right? Then we can see here that moment of inertia of a rectangle about the x-axis, right? Ixx is equal to what? bd cube by 12. Okay, and when you have to find out the moment of inertia about the y-axis, that is db cube by 12. All right. Now next we have a next geometrical shape which we will learn, that is your triangle. So let's say this is the triangle, right? And the name of the triangle we can specify that A, B, and C. This base is AB, is B, sorry, right, and the height of the triangle is nothing but the H, right. So that if you locate the center of gravity of the triangle, the center of gravity of a triangle is means centroid of a triangle is at the point of intersection where the medians are intersecting. So one of the median is this one, right, and another one is this, and another one is this one, right. So this is the center of gravity, centroidal axis, like this. That is for y axis it is h by 3, and for base axis it is b by 2, right. So in this case, when you have to find out the moment of inertia of about the two ways, that is about the base of the triangle and about the centroidal axis, right. So first of all, we will see the moment of inertia about the centroidal axis, ICG. ICG means what? The moment of inertia about the centroidal axis. So let's say that this is CG. There is no confusion, right? So this will be BH cube by 36, right? So most of the time the people get confused, right? So need not to be confused. Whenever you have to find out the moment of inertia about the centroidal axis, you should use this relation. Next we have a moment of inertia about the base. So it AB, right? Don't think so it is x and y axis right now. So it is the BH cube by 12. All right. Next, we'll further move to the next geometrical figure, which is the circular. Now, so next you can draw one circle. As I told you that means this is the diameter of the circle, this is the center. Let's say the diameter of the circle is D, right? Let's say the diameter of the circle is D, right? So moment of inertia about of a circle about x and y axis will be same. Why? Because the centroid of the circle is at the center, or you can say the radius from the edge, right? So you can say Ixx is equal to Iyy, that is equal to pi by 64 d to the power of 4. All right. Okay. Final, we'll see one more geometrical figure, that is your semicircle, right? So it is the semicircle, right? So for if the semicircle is kept like this, its centroid will be at the about x-axis will be the radius, okay, and about y-axis it is 4r by 3 pi from the base. From the base means what? From here, right now. So that we already discussed. If you have a doubt, you can go with the previous videos, right? So this is what you can say. Moment of inertia is about the xx or about the yy is equal to what? Pi r to the power 4 by 8. Okay, so these are the few geometrical shape we have discussed, means whose moment of inertia we have discussed. Now whatever the topic we covered till now, based on that we'll try to solve one numerical problem, that how we can find out the moment of inertia of a given shape. So we have a problem on the screen. You can firstly copy this, why? Because time is already right. So here I am dictating the problem. See, find the moment of inertia of the section about horizontal axis, right, and vertical axis passing through the center of gravity of the section. So the section is given, that is the T section is given. That section is on the screen. That question is what? The question we have the find the moment of inertia of the section about horizontal and vertical axis passing through the center of gravity of the section. So this is your section is given, that T section. The dimension is what? 100 into 2, and again that this is 8 into 2, right? Why? Because the total height of the T section is given 10, but the wave height is what? Wave height is means this 2 you have to subtract. So it is 8 into 2, right? So its center of gravity you have to find about the horizontal as well as about the vertical axis. So before finding the moment of inertia, you should know that given section is symmetrical about the which axis, right? Why? Because first of all we need to locate the center of gravity. Okay, So as you can see this, that this section is symmetrical about the y-axis. Why? Because if you cut like this, okay, if you cut like this, so you can't get the two equal weight. It means it is not symmetrical about the y-axis, but x-axis. But if you cut like this, means if you cut the section about the vertical axis, you'll get the two equal weight, which means that the given section, the given T section is symmetrical about the y-axis, right? So now first of all you need to find out the y coordinate, that is center of gravity about the y-axis. Very fast we'll go. That section is having two part. Let's say this is the one, let's say this is 1 and this is the 2, right? So y bar is what? That simply you can say y bar is that you can write those statement that the given section is symmetrical about the y-axis, right? So that you can write y bar is equal to a1 y1 plus a2 y2 upon a1 plus a2. Okay, now a1 is equal to what? Let's see this. I consider this as a 1, right? This wave as a 1. So one section is what? This width is 2 and the height is what? The total height is 10. From here to here it is 10, but we have to find out the height from here to here. It means that this 8 is there. Why? Because 10 minus this 2 you have to subtract. So area is what? Area is nothing but the 8 into 2. So very fast you can write 8 into 2 is 16, that is centimeter, right? And for this top flange, the area is what? This is 10 and this is 2. This rectangle length into width, right? So you can say here that A2 is equal to 10 into 2 means 20 centimeter. Alright, now then we will find out the y1, right? So y1 is what? That y1 is nothing but the half of the depth. It is a rectangle. So y coordinate is what? D by 2 and D is what? 8. So you can say the y1 is equal to 8 by 2 means 4 centimeter. Okay, and y2 is what? That 2 is located, this is your reference, right? This is your x-axis and this is your y-axis. So this flange is located at a distance of 8 centimeter from the base, right? Means from the OX axis. So it means that this distance you should add, right? So these all things you know already right now. So y2 is equal to 8 plus 2 by 2 means what? 9 centimeter. Okay, now these data we will substitute into this equation, we'll get the y bar. Okay, now see here, you can simply put those data in the above equation, that here y bar is equal to a1 y1, a1 is what? 16, y1 is 4 plus a2 y2, 20 into 9 by a1 plus a2, a1 is 16 plus 20. So y bars will get some values. Right, so y bar you will get that 6.77 centimeter. From where? From the base, right? So first of all we will locate the centroidal axis. So let's locate the centroidal axis. So let's see, the total height of the section is what? 10 centimeter. We got the center of gravity about the y-axis is 6.77. So if you see that half of that is what? 5. So it means that more than the half. So let us imagine the centroidal axis is lying here from the base, right? So this is your centroidal axis CG and you can measure the height, that is this is 6.77. all right. Okay, now you have to find out the moment of inertia of the given section about the horizontal and vertical, means about x and about the y. So first of all you say that you need to think that whether it is symmetrical about x-axis or not. So the given section is not symmetrical about the x-axis, okay, but it is symmetrical about the y-axis. So it means that when we have to find out the moment of inertia about the x-axis, we will use the parallel axis theorem. Why? Because that centroidal axis is not on that on the x-axis, right? Means so not lying on the horizontal axis, but it is symmetrical about the y-axis. So simply we will use the formulas, right? So here you can, yes. So now you can see this, that just I write down one point, right? It will be useful for you people, that just hold on, right? Okay, see here. So we can make a point that for y-axis, for x-axis, we will use the perpendicular axis, parallel axis theorem, right? Parallel axis theorem. Since the given section is not symmetrical about what? About x-axis. So whenever the given section is not symmetrical about that axis, to get the moment of inertia about that axis, we will use the parallel axis theorem. Okay, now, so how many part is there? How many shape in that given section? The two shape, right? So you can say the Ixx is equal to what? Ixx1 means for the wave plus Ixx2. Okay, for finding this Ixx1, we'll apply the parallel axis theorem. So what is that Ixx1? That Ixx1 is nothing but the Ig1 plus A1 H1 square, right? And so first of all, this Ig1 is what? Moment of inertia about the centroidal axis, means Ig1 we will find out the B1 D1 cube by 12. Means what? That B1 D1 cube is nothing but, see here, this is your B and this is your D, right? For this it is B2 and this is the D2, right now. So now B1 is what? 2 into D is 8 cube by 12. We'll get some value, let's leave. A1 is equal to, we already know, that is 8 into 2, see here. So 8 into 2, that is 16 centimeter square. And when you have to find out the moment of inertia about the x-axis, so h is equal to what? Y bar minus y1. So h1 is equal to y bar minus y1. So y bar is what? 6.77 and y1 is 4, right? So y1 is 4. We'll get some value. Now this data we will substitute into this equation. So finally you can say that Ixx1 is equal to what? That 2 into 8 cube by 12 BD cube plus A1 means 16 into 6.77 minus 4 whole square, right? Okay, now so this value you'll get some value, that is 105.301. Moment of inertia unit is centimeter to the power 4. Next you can say Ixx2. Simply what is that Ixx2? That Ig2 plus Ig2 plus A2 H2 square. So can I substitute directly? Yes. B2 D2 cube, B2 D2 cube by 12 plus A2 into Y bar minus Y2 whole square. So what is B? B is the 10 for the top flange and D is the 2 cube by 12 plus area is what? 20 into 6.77 minus 9 whole square. We'll get the Ixx2, right? So this data is nothing but a 208.72 centimeter to the power of 4, sorry, right? So simply you can add, so you can say Ixx is equal to Ixx1 plus Ixx2. So when you add these two values, you'll get the Ixx is equal to what? That Ixx is 314.22. 314.22. You can cross check, right? Maybe there is a human error, centimeter to the power of 4. So moment of inertia about the horizontal axis we calculated, right? Now then we will find out the moment of inertia about the vertical coordinate, right, which we call it as a y-axis. So let's go that, and then it is symmetrical about the y-axis, so need not to find out the need not to apply the parallel axis theorem, right? So simply moment of inertia about the vertical axis, you can say moment of inertia about what? Vertical axis. Okay, so moment of inertia about vertical axis is what? Your Iyy is equal to Iyy1 plus Iyy2, right? So Iyy1 is equal to what? that wave is rectangle and the flange is also rectangle. So it is d1 b1 cube by 12 plus d2 b2 cube by 12. Alright, so d is what? D is the 8 and b is the 2 cube by 12 plus d is what? 2 and b is the 10 cube by 12 simply. So you will get the answer that Iyy after simplification you will get the 172 centimeter to the power of 4, right? So this is the how we can find out the moment of inertia about the horizontal and vertical axis, right? So in next class we will solve few more problems, basically the composite section and the cutout section moment of inertia, right? So please be updated with the channel. Thank you.